Hello everyone, welcome back to another math team video. This time I'm going over this problem, problem 3 from 2016. And this is, by the way, it's round 3 from match 1. Alright, so we have the median of an isosceles trapezoid measures 10 centimeters. Okay, so first of all, let's look at the most important term here, which is isosceles trapezoid. That basically means that, these two are the same length. So that's basically all it means. And it also means that they're at the same angle. Alright, that's about it. And the median, the second most important term there, is basically that line. It's directly in between the it's half of the height, so that's where it's placed, and then it goes all the way horizontally from this point to that point. So that would be the height. Alright, anyway, continuing. We know that this is 10 centimeters, and the area of the entire trapezoid is 35 centimeters squared. But we can just write A equals 35. One of the angles on the trapezoid measures 45 degrees. So we know that can only be, basically that angle. That's the only one that would make sense. And then find the perimeter of the trapezoid. Now, when I say it has to be, this one over here, it could also be oriented upside down. However, it'd be basically the same trapezoid, just reflected. So we can just look at it from this perspective. Alright. Now the goal is to find the perimeter. So we're definitely going to need the lengths of basically the hypotenuse on that right triangle, which is the same as the hypotenuse on that right triangle. And from there, we can kind of just extrapolate the above and the below. Alright. So, let's see. Our first step might be to establish that the area of this trapezoid is 35 centimeters squared, and then put that in an equation using the height and the length. And by the way, when I say length, what I mean is essentially just 10, because the median times the height, the h there, so 10 times h is actually equal to 35, the area. And why is that? Well, in an isosceles trapezoid, you can kind of imagine making a slice there, so at the point where the median touches the side, and then taking that right triangle, let me use red, so that right triangle, we can move it up and to the left to fill in that slot, and then if you do that, repeat that on the other side, you basically end up with a rectangle. And this is only possible because it's an isosceles trapezoid. So if that doesn't make sense, just kind of think about how, these two triangles are actually the same, and then that square or rectangle is double their size of one of the right triangles. And then you can put two right triangles together in there, and it'll make the same area as the rectangle there. So we can establish that 10 times the height, which is, like that, equals 35, and we now know that the height is equal to 3.5 centimeters. So that was pretty easy, but you did have to know that property to actually get it done. However, once you use that property, the problem becomes much simpler. Alright, so from this point, we can actually figure out basically, let's see. Yeah, using the idea of the special right triangle with 45, 45, 90, we can actually get the side length ratio. So it's square root of 2 on the hypotenuse, and then it's 1 and 1 on those sides. And since we know that for our left side there, let me look at this right triangle that we're going to use. So it's basically that right triangle. And we know that since the height is 3.5, this side is actually 3.5. And then we can get the hypotenuse length by using this ratio. So it would be 3.5 times square root of 2 equals x. Alright, so x equals 3.5 times square root of 2. Okay, I got a bit ahead of myself. Right, so it equals that. Now we know that basically if that's the length of one hypotenuse, then the other one also has to be the same on the right side. So we can times 2, and we get 7 square root of 2 for our lengths, or the sum of the lengths of the diagonals. Now the only problem is, how do we know actually like the top and the bottom? So that's an interesting question. And we could use our right triangle to again derive that length on the bottom, like the bottom, which is 3.5. So since there's 3.5 on both sides, naturally it would insinuate that, well, it wouldn't actually tell you much. I guess since that the point where the median touches the sides, the diagonals, is actually halfway in between in terms of the horizontal, you can use 1.75 plus 10 and then plus 1.75 again, since, you know, if the bottom is 3.5, then naturally half of that would be 1.75, and then you could tack that on, like move left, and you would extend to the bottom length, and you'd get that sum, which is 13.5 for the bottom, and then you would get 6.5 because you can subtract, right? Subtract 1.75 twice from 10. You add that together, you get 20. But for isosceles trapezoids, we can use a similar property that we used earlier, and that property is that basically the top plus the bottom, those lengths, actually equals double the median. And that might actually be true for every single trapezoid. Let me think about it. Let's see. So I mean, it kind of has to be true, right? Because it's essentially like a linear scaling, and if you go to the midpoint, it would be always kind of just be double. Yeah, when you add the top and the bottom, it should be the same as the doubling the middle for every single trapezoid. So essentially 20, this will be our answer, because 2 times 10 is 20. But also we can use that method of adding the 1.75s and subtracting for the top. That way we'll get 20 anyway. So our answer will be 20 plus 7 times the square root of 2 centimeters as our perimeter. That's it for this video. Thank you guys for watching, and see you guys next time.